Almost everything you have been taught about hunger is backwards. Most people believe that the moment they skip a meal, their body starts running out of energy. Skip enough meals, and your brain slows down. Your muscles begin breaking down. Your body slips into survival mode. It sounds obvious, except that is not what your biology was designed to do. For nearly all of human history, food did not arrive 3 times a day. It arrived when you found it, which raises a fascinating question. How did a species survive millions of years if missing meals immediately made it weaker? Imagine you are standing on an open plain 50,000 years ago. There are no grocery stores, no refrigerators. The last successful hunt was yesterday. Since then, you have walked mile after mile with nothing to eat. The sun is beginning to set, your stomach is empty, and tomorrow's meal is not guaranteed. Now think about what that really means. If hunger immediately made humans weak, distracted, and incapable of thinking clearly, our species would never have survived long enough to build civilizations. Evolution could not afford a survival strategy that shut the brain down the moment food disappeared. It needed the opposite. The longer the hunt continued, the more valuable clear thinking became. Better decisions, sharper attention, greater endurance. Every hour without food increased the importance of finding the next meal. So instead of treating the absence of food as a system failure, your body treats it as a signal to change the way it produces energy, to unlock a fuel reserve that has been stored for exactly this moment, to conserve what matters, to repair what does not, to prepare you to solve the problem that matters most. Finding food. That survival program never disappeared. It is still built into your biology today. Most people interrupt it before it ever has the chance to fully activate. Somewhere, after your last meal, your body stops expecting food and starts preparing to function without it. Your metabolism begins following a completely different set of instructions. Instead of constantly searching for incoming fuel, your body starts using the energy it has been storing all along, and as that transition unfolds, an extraordinary chain of events begins. Your brain starts running on a different fuel. Your hormones completely change their priorities. Deep inside your cells, repair programs that spend most of modern life sitting idle begin waking up. This is not biohacking. It is not a diet. It is biology doing exactly what biology evolved to do. So let us watch it happen, hour by hour, hormone by hormone, molecule by molecule. Because the first surprise is this. For the first 12 to 18 hours after your last meal, your body barely notices anything has changed. Your liver is stocked with glycogen, a branched chain of glucose molecules built for exactly this situation, roughly 80 to 100 grams of it, tucked away like a fuel line running straight to the engine. As that glycogen empties, a hormone called insulin, which spikes every time you eat carbohydrate or protein, starts to fall. And as insulin falls, a second hormone, glucagon, rises to take its place. Insulin and glucagon are opposites, made by neighboring cells in the same organ, the pancreas. One says, store, the other says release. Your body cannot run both signals at full volume at the same time, which is exactly why they take turns. Somewhere past that 18-hour mark, glucagon crosses a threshold, and a second, much bigger fuel tank gets unlocked. It is called lipolysis, the breakdown of stored fat into usable fatty acids. Think of your liver's glycogen as the fuel line right at the engine. Instant, but tiny. Your body fat is the tanker truck parked in reserved tens of thousands of calories, sitting there the entire time, completely disconnected till the right hormonal valve turns. Low insulin is that valve. Once it turns, fatty acids start pouring into your bloodstream by the thousands. There is a problem, though. Your brain cannot burn fatty acids directly. They cannot cross the blood-brain barrier in usable form. So your liver runs one more conversion, called ketogenesis, turning fatty acids into small, water-soluble molecules called ketone bodies, mainly one called beta-hydroxybutyrate. Unlike fat, ketones cross into the brain easily. And they do not just substitute for glucose as fuel. Some research suggests they may burn cleaner, generating less oxidative byproduct per unit of energy than glucose does. This is the mechanism behind something a lot of people report and very few can actually explain. The mental clarity that tends to show up on day 2 of a fast, instead of the fog you would expect. Here is the part most explanations skip. Ketones cover most of your brain's fuel needs, but not all of them. Some cells, like your red blood cells, have no mitochondria at all and can only run on glucose, full stop. So your liver keeps a side operation running the entire time called gluconeogenesis, literally making new glucose, built from amino acids and a byproduct of fat breakdown called glycerol. Nothing in this system is actually left stranded. There is a backup for the backup. This entire cascade, glycogen, insulin, lipolysis, ketones, has a name in the research literature. Johns Hopkins University neuroscientist Mark Mattson, who spent decades studying intermittent fasting at the National Institute on Aging, calls it the metabolic switch, the point where your body's primary fuel source flips from glucose to fat-derived ketones. Mattson and his co-author, Rafael de Cabo of the National Institute on Aging, reviewed the evidence in the New England Journal of Medicine and concluded that most people never flip this switch, not for weeks, sometimes not for years at a stretch, not because they are incapable of it, but because they never go long enough between meals to trigger it in the first place. And that switch is what finally opens the door to the process I opened with. Once ketones are running the show and insulin has bottomed out, a molecular sensor called AMPK activates inside your cells, while a separate pathway called mTOR, which normally tells cells to keep growing, it's suppressed. That combination is the ignition switch for autophagy. Cells start identifying their own damaged parts, misfolded proteins, worn-out mitochondria, molecular debris that has been quietly piling up for months. They wrap it in a membrane, break it down, and recycle the pieces into new components. Japanese cell biologist Yoshinori Osumi mapped out these mechanisms using yeast cells in the 1990s, work that won him the 2016 Nobel Prize in Physiology or Medicine. He did not discover that cells could do this. He discovered exactly how, gene by gene. Here is the way to think about the bigger picture. Every cell in your body runs in one of two modes, growth or maintenance. It cannot fully run both at once. Under a constant stream of food, insulin, and glucose, your cells stay locked in growth mode almost permanently, building, storing, replicating, but never stopping long enough to clean house. Autophagy is what happens the moment you finally let maintenance mode take over. I wanted to know if any of this actually showed up in something I could measure on myself. So I tried it. I ran a 16-8 eating window for 6 weeks, stopping dinner at 7 p.m. Not eating again until 11 a.m. Nothing else changed. Same total calories, same food quality, same training schedule. Before, my 3 p.m. slump was reliable enough to set a clock by, a wall of fog that coffee barely dented. By week 2, it was gone. Not reduced, gone. I also tracked my fasting blood glucose with a basic at-home monitor. It started around 98 milligrams DL. By week 5, it was sitting consistently closer to 88. That is not a dramatic transformation, but it is a real, measurable shift in how efficiently my body was handling fuel, achieved by changing nothing except the timing of when I ate. The bigger surprise, honestly, was mental, not euphoria. Just a flatter, steadier line all day, instead of the usual spikes and crashes I would stop noticing because I would never known anything else. So why does this actually work? At the level of your biology, a handful of specific mechanisms are doing the heavy lifting. Reason number 1. Your muscle cells get better at listening to insulin. Every cell that responds to insulin does so through receptors on its surface. Keep insulin elevated around the clock for months and years, and those receptors gradually stop responding as strongly, a state called insulin resistance. Nutrition researcher Courtney Peterson at the University of Alabama at Birmingham put pre-diabetic men on early time restricted eating window, finishing meals by mid-afternoon, while deliberately holding their calorie intake and body weight completely constant, and still found meaningful improvements in insulin sensitivity within 5 weeks. Same calories, same weight lost, which was 0 by design. Cells that responded to insulin like a noticeably younger metabolism, purely because of when the food arrived. Reason number 2. Growth hormone rises to protect your muscle. During a fast, your pituitary gland ramps up excretion of human growth hormone, with research showing levels climbing several-fold within a day or two of continuous fasting. Its job here is not bodybuilding, it is preservation, a signal telling your body to hang on to lean tissue and pull energy from fat stores instead. Compare that to constant grazing, where growth hormone secretion stays relatively flat because your body has little reason to protect muscle and fuel is always one bite away. Fasted muscle gets defended. Fat muscle gets ignored because it does not need defending yet. Reason number 3. Your gut gets its own dedicated cleaning cycle. Between meals, and only between meals, your digestive tract runs something called the migrating motor complex. A wave of strong, sweeping muscle contractions that moves through your stomach and intestines roughly every 90 minutes to 2 hours, clearing out leftover food particles, bacteria, and debris. The moment you eat again, even a small snack, that waste stops completely and resets from zero. Graze all day, and your gut never finishes a single cleaning cycle. Fast for several hours, and it runs the cycle uninterrupted, start to finish, over and over. Reason number 4. The same ketone molecule fueling your brain is also telling it to grow new connections. Beta-hydroxybutyrate, the ketone I mentioned earlier, does not just act as fuel. Inside the brain, it also functions as a signaling molecule, boosting production of a protein called brain-derived neurotrophic factor, or BDNF, which supports the growth and survival of neurons. Mattson's own research has linked this same pathway to improved learning and stress resilience in animal studies of intermittent fasting. More fuel efficiency is one thing. A brain chemically nudged toward building new connections, while you are not even eating, is a different thing entirely. Before we get to execution, one more mechanism worth knowing, because it is the thing that actually makes fasting feel hard. Hunger itself is not a straight line. It is driven largely by a hormone called ghrelin, released mainly by your stomach, and ghrelin does not just climb steadily until you eat. It rises in waves, peaks, and then falls again on its own, roughly tied to your normal mealtime habits, whether or not food actually arrives. That gnawing, urgent hunger at hour 14 is not a warning sign. It is a wave. And like every wave, it crests and recedes, usually within 20 to 30 minutes, whether you feed it or not. None of this works so if you get the execution wrong. And this is where most people trip up. Mistake number 1. Breaking the fast with a large, sugary meal. That spikes insulin, right back to its peak within minutes, and cancels out a meaningful chunk of the metabolic benefit you just spent 16 hours earning. Mistake number 2. Treating the eating window as a free-for-all. Fasting changes when you eat, not the laws of energy balance. Calories and food quality still matter for weight and body composition goals, window or no window. Mistake number 3, jumping straight into a 20-plus hour fast on day 1. That is a shock most bodies are not adapted for, and it frequently backfires into overeating the moment the fast breaks. Mistake number 4, ignoring hydration and electrolytes. A lot of the headaches and fatigue people blame on fasting itself are actually just dehydration and low sodium, easily fixed with water and a pinch of salt. If you want to build this properly, here is how to progress. Step 1. Start with a 12-12 window, simply closing your eating hours to normal daytime, nothing more aggressive than that. Step 2. Move to 14, 10, then 16, 8, over 2-3 weeks, not 2 to 3 days. Step 3. Once that feels genuinely comfortable, experiment with an occasional longer fast, 20 to 24 hours, as an occasional tool, not a daily habit. Step 4. Track how you actually feel, sleep, and train, not just the number on the scale, and let that real data decide your next move. And before any of that, this is not for everyone, and that matters more than any benefit I have just described. If you are pregnant, breastfeeding, or trying to conceive, skip it. If you have a history of an eating disorder, skip it. If you are a child or adolescent, your body is in a growth phase this protocol is not designed for, skip it. If you have type 1 diabetes or take any medication that affects blood sugar, this requires direct medical supervision, not a YouTube video. And if you are underweight, malnourished, or recovering from a major illness, your body needs consistent fuel right now, not less of it. Even outside every one of those categories, a quick conversation with your doctor before you start is just good sense. There is one more piece of this that reaches far beyond energy and cellular cleanup, and it involves that same ketone molecule from earlier. Beta-hydroxybutyrate does not just fuel your brain and trigger BDNF. Immunologist Vishwadeep Dixit and his team at Yale School of Medicine found that this same molecule directly blocks a piece of your immune system called the NLRP3 inflammasome, a structure inside immune cells that, when chronically overactive, drives the kind of inflammation linked to conditions like type 2 diabetes, gout, and atherosclerosis. In other words, the exact molecular byproduct your body makes while fasting is also a natural brake on one of the primary drivers of age-related inflammation. That is a large part of why intermittent fasting keeps showing up in research tied to metabolic disease risk generally, not just weight. The mechanism reaches into your immune system, not only your fat cells. Dixit's lab has since extended this line of work into long-term human caloric restriction studies, tracking how sustained energy deficits reshape immune aging over years, not just hours. The short version: the same hormonal shift you trigger with a 16-hour fast and the shift studied in multi-year human trials appear to be pulling the same lever, just to different depths. So here is the simple version, distilled into steps you can start today. Step 1. Pick an eating window, 12 hours to start, 8 hours once you are genuinely adapted. Step 2. Keep the first 2 weeks flexible and let your body adjust before tightening anything further. Step 3. Break your fast with protein and fiber first, not sugar. Step 4. Track energy, sleep, and workouts, not just the scale. Step 5. If you fall into any of the higher risk categories I mentioned, talk to a doctor before you start. No exceptions. Glycogen depletion. The insulin to glucagon handoff. Fatty acids unlocked. Ketones feeding your brain. AMPK and mTOR flipping the switch. Autophagy clearing house. Growth hormone protecting your muscle. Your gut running its own overnight cleanup. That is the whole cascade. And it is running on a script your biology has carried since long before agriculture existed. If this changed how you think about hunger, hit subscribe. Feynman Decoded puts out a video like this every week, and the mechanism behind your next habit might already be sitting in the queue. Try 1 week of a 12-hour window and tell me in the comments what changed first for you. And if you have got a friend who white-knuckles through a 3 p.m. crash every single day, send them this one. Your body has been running this program for longer than it has had a name for it. It has just been waiting for you to stop interrupting it.